Olá, voltamos com a segunda parte do módulo Uso de metadados para a melhoria da qualidade de streams de áudio e podcasts. Será apresentado pelo engenheiro John Kean.
So here's some examples. I have 3 examples starting with the original piece of music. It runs 1 minute, and you can see down here, I hope my mouse pointer is visible, you can see the left and right channel waveforms of the audio over that 1 minute period. In the little overlay, I've included some information from that ITU loudness measurement. You can see that it's a -24 LUFS. That's the ideal target level for the audio. And the loudness range is 14.8 LU. Well, an LU is equivalent to a decibel, and I'm sure you're all familiar with decibels. So that gives you an idea of the loudness range in this. It starts at a medium level, it then has a burst, as you'll hear, and then it goes into a quiet period in which it builds up in loudness to a big climax at the end. It's really a delightful sounding clip, and it was produced by Sean Singh at Google, who's a member of our AES committee. So at this point, I'm going to click on the play. If you're using the PowerPoint slide deck later, you can play it back for yourself, but I'm going to start with it back right now. Okay, you may have seen me smiling there. It's the kind of music that will actually make you smile a bit when you listen to it, and it's really delightful. Now, if you had adjusted your volume control to get a comfortable playback level for that might be what is best for your listening environment and for your playback equipment. But suppose you were listening to this particular piece of music in a little noisier environment. You were in your kitchen, and there's other background noise going on, preparing dinner. Well, it may be that there you want a little less range, and you want more loudness. You want it to move up. Well, you don't have to do anything to the audio in its source. We're using the very same audio file that you just heard. The only thing we're doing here is telling the decoder to read the metadata and elevate the level by 6 LU or 6 dB. Now you can see that in the waveform diagram here. You see how the opening peak got much higher than the preceding slide. It increased the loudness all the way across. One of the nice things about MPEG-D is that it also has a peak limiter built into the decoder, so that if you increase the gain of the playback as desired, it will prevent overload in the playback system, because it will recognize a peak and it will limit it before it ever gets to your loudspeakers. So we're going to play the next one. This one has been raised to about -18 LUFS, that's 6 LU or 6 dB increase. And notice that the loudness range has dropped now by about 3 dB, 3 LU. And that's because there's a little bit of compression going on in this. It's still very pleasant, and you really don't hear much of that compression effect. And here we go. Okay, so that was clearly louder in my earbuds right here. I didn't touch the volume control. Now you might be asking yourself, well, what's the difference between this and just turning up the volume control on my player? Well, it has some of the same effect, but we started with the same source material and we reduced the dynamic range to make it more satisfactory in a noisier environment. And that's the difference. The dynamic range was changed. We didn't just turn all of the music up together. Now you'll hear that even more in the last audio demonstration. Here I've really cranked up the dynamic range control, the DRC, and I've taken that very same file that we started with, and I've told the player to increase the loudness, and in this case up to -14. So that's a full 10 dB increase from the original file and where it plays out. And yet there's no overload in the audio. You can see the peaks are pretty substantially controlled, especially down here on the right channel. You can see it's the built-in limiter was really working to protect against amplifier and speaker overload. It also reduced that loudness range to under 10 LU. So there's about a 5 dB reduction in dynamic range. This might be the kind of audio you would want to hear if you were riding on the bus and you wanted to make sure you heard all of the music or all of the voice without any drop. So here we go. Okay, so again, that was a fun piece of music. For you audiophiles out there, I know you'll notice the reduction in the dynamic range. It's been flattened the way we hear a lot of compressed music these days, but in some cases, that's what the listener needs. The nice thing, this is the real takeaway about audio metadata and MPEG-D dynamic range control, is that it's now in the hands of you, the listener. You can send out high quality content and the listener can decide how much they want to reduce the dynamic range for their listening environment or their own taste. So that we're very excited about, and we think this is going to be a real sea change for the audio industry. So, as I mentioned, for next steps, the Audio Engineering Society Technical Committee on Broadcast and Online Delivery, which is an international committee, by the way, and we certainly invite members from Brazil to participate in this subcommittee. And we are now finishing the technical document, 1004, that is probably a month away from being completed. And then it will go through some internal review processes and be released as a new technical document. And we hope next year it will become an AES standard. If you wish to contact us and participate, or you have questions, you can write to David Bialik, who's at the bottom of this screen. There's his email address through the Audio Engineering Society. So I hope you found this of interest, and look forward to hearing back from you with questions and I hope participation. Thanks very much. Okay.
Thank you so much, John. It's brilliant,
Oh,
as
good.
always.
Well, wait till
Oh,
you hear
gosh.
the music.
I
I don't think you heard the music, but
No.
you could see what was going on with the waveforms there, right?
Yeah, yeah. Sure.
It
It's impressive.
it's like having you work with broadcast audio processors, of course. It's like having a broadcast processor in the little audio chip in your smartphone. It's already built in there, and the nice thing is you can leave it up to the listener as to how much dynamic range they want from the audio, and at the same time it will eliminate this unevenness where if someone goes from your stream to somebody else's stream or to a podcast, the level, is not going to suddenly jump again and become annoying.
We will have other speech on the same module. We invited Bob Orban to talk about audio processing for on-air transmission, as well people from Omnia. And we will have also on the other side, the people from the podcast industry, including the programmatic media company called Audio Ad, and they do the dynamic insertion of the audio advertising into the stream. So we listen a lot, not from them, but we listen a lot this kind of difference between the streaming and the advertisement inserted, the spot inserted into the streaming. There is no standard for that, so it's annoying, really.
So one of the nice things with MPEG-D metadata and dynamic range control, no more loud commercials to annoy you. Now, your advertisers might not like that, but the listeners definitely will. And and by the way, Bob Orban is a member of my committee.
Oh, really?
Yeah, we have Bob Orban, Frank Foti.
Yeah, we invite
both sides, and so they are participating. In a way, you might say this is going to reduce the need for buying expensive audio processors to go out on streams or podcasts, but they realize that this is really the future of audio, is being able, just like with television, to deliver all the dynamic range the listener wants, or as little as they want. And it's up to the listener, not a sort of one-size-fits-all solution. So that's so fortunately, yeah, Bob Orban is a wonderful engineer. I really look up to him, and he's been a great help in writing our technical document. So that's
I've already experienced not just the high commercial spot, but the very low. You couldn't hear what they say. So this is a loss for the advertisement, the sponsor.
That's true.
So we have to find a way to balance that. It's a win-win relation.
Well, if you encode in high efficiency AAC, also known as AAC plus, then the capability to use the metadata is already there. You can start adding audio metadata, and it can be used in the player right away with minimal software. So,
Wonderful.
so I think it's going to be a nice step forward. I'd love to work with you on that. See, you have to let me know if I can help you.
Okay. So again, thank you very much. Thank you very much for your time. Thank you very much for sharing your knowledge.
All right. Well, thank you all very much for your help. It was a pleasure to work with you today.
Thank you very much. Obrigado, John, pela apresentação e pela participação na trilha 7 Rádio do 7 Experience Academy.